So we're going to look now at a full example, and this is about Wellington Airport and flights. There are four conditions you have to learn for the binomial distribution. There is always two options. There's always a fixed number of trials. There's always a fixed probability, and each trial is considered independent. And you're expected, when you read a problem in the exam, it's not going to say binomial. You're expected to look out for that. So here's a situation that fits it. At Wellington Airport, there's an 85% chance a flight leaves on time. In one afternoon, there is exactly 12 departures. The first job, and this is not the easiest, is to justify. Now, how you might go about this is like this. So two options. What are the two options? On time or not. So it fits that. And over in this one here, I'm commenting on whether it's a really good fit or not, because this is a model. It's not a perfect science. Fixed number of trials. And again, there's 12 flights. It's a precise number. It's discrete. And also that's a good fit. Fixed probability. Now, in this, because this is where it starts to get shakier, we've been given a probability of 0.85. In practice, though, we could be a bit skeptical of that. And whether that is a fixed probability is unlikely. Things like weather, flow-on effect of delays in another airport, that could see this change, and it might not always be exactly 0.85. It might average to that. And then trials are meant to be independent. And again, this is usually the shaky one. The timeliness of one departure does not impact another departure. That's what independent means. But in practice, really, anyone who's spent much time in an airport knows that's a stretch. Departures are caused by factors like weather that could likely impact all flights or given on a given day. And so, are the flights completely independent? No. Okay, so there's a separate clip about how to deal with this on the calculator, because the beautiful red formula can be dodged if you know how to drive your calculator properly. Then you'd be silly not to. So here's standard sort of 5 questions. What is the probability all flights leave on time? Now, actually, if they ask you that, you don't need to know anything about binomial distribution whatsoever. You can just use your common sense. That would be 0.85 times 0.85 times 0.85 times 0.85 times 0.85, all the way through to 12 of them. If you multiply them all out to the power of 12, you get that. So a 14% chance they all leave on time. Okay, binomial cuts in now. What's the probability that exactly 8 flights leave on a time out of 12? Now, in red, we've got the number of orders. You don't want to list this because there is 495 of them. And you could just go 12C8 on your calculator and get that. Okay. 0.85 to the power of 8. That is the 8 flights that leave on time. 0.15 to the power of 4 are the 4 flights that don't. And the 8 plus the 4 have to add to the 12, because the 12 is the guiding figure. I can multiply that all out, or if you look at the clip for using the calculator, I can go to BPD with x equals 8, num trial, and 12. Num trial is 12, probability 0.85, and I can go straight to the answer. So I've got 2 ways I can get it, and I recommend you do them both. What is the probability of up to 6 flights depart on time? Now, that means that's 0, 1, 2, 3, 4, 5, and 6. Now, you don't want to do this manually. That would be a real drag. When you go to binomial on the calculator, you've got PD. That little p stands for one particular value. C stands for cumulative up from 0. So if I put in x equals 6, num trial 12, probability 0.85, so they haven't changed, it will give me that. It will throw in a bit of standard form. So I've got to move my decimal point to the left 1, 2, 3 spaces. It's actually a really small probability. of that happening. Okay. What is the probability 8 or more flights leave on time? Now this gets tricky, but the limit on the calculator is I can't do 8 or more. What I can do is 7 or less. It's a standard rule in probability that if I go 1 minus, and what I'm doing there, if I put this in brackets, I'm doing 1 minus the probability of what I don't want. Okay, the leftover stuff. And so that's a common trick in probability speak, just speeds our life up. Okay, I don't know, I'll make that pink. So I can calculate the probability of the 0 through to 7, and we want the rest of them. And so we go 1 minus that. Now again, we're not going to do this manually. We're going to use a calculator, and we're going to find BCD. There's a separate clip on how to do that, and you've got to give it a go.